Good evening, dear students. This side Dr. Manashi Mukhapadhya. Today again we have met to discuss on certain issues of periodic properties, certain issues on periodic properties of the elements of the atoms. Last day we discussed about ionization energy, and today we are supposed to discuss about electron affinity. Now, what is electron affinity? To understand that, first we have to remind once more ionization energy. Ionization energy is the amount of energy required to release one electron from the outermost orbit of an isolated gaseous atom. So it is the amount of energy absorbed and the electron at the outermost orbit is released. Electron affinity is exactly the opposite, the reverse concept of ionization energy. Electron affinity is defined as the amount of energy released to take one electron in the outermost orbit of an isolated gaseous atom. Formally defining, electron affinity is the energy change that occurs at an atom when gains electron. Now, what is the trend of electron affinity? Same like ionization energy. It increases in the periodic table from left to right and it increases from bottom to top. So if we go on like this, we will be having a trend like this. If this is the periodic table, it will increase from bottom to the top in the periodic table and from left to right. Now, next comes to be physically defining electron affinity. Electron affinity reflects the ability of an atom to accept an electron. It is the ability, it is the mode of acceptance of an atom to accept electron in the outermost orbit of the valence shell. It is the energy change that occurs when an electron is added to the gaseous atom. And naturally, atoms with stronger effective nuclear charge have greater electron affinity. More the charge, the positive charge at the center, more it will be attracting the outermost electron to be added to the outermost orbit. And the reaction that occurs when an atom takes an electron may be represented like this. X is an isolated gaseous atom. It takes up an electron represented by E minus. So X, as it accepts, we are giving it a plus sign. X plus E minus, that leads to X minus. Now X is having more electrons, so the charge is negative. Plus energy, that means energy is released. Plus energy is in the right hand side of the arrow, that means energy is released. So the formal representation of ionization energy is X, which is an isolated gaseous atom, plus E minus leading to X minus plus releasing energy. Another way to define electron affinity is the amount of energy needed to remove the electron from a singly charged negative ion. That is what I said. This is actually the definition of ionization energy. So ionization energy and electron affinity are exactly opposite. So they only differ in the sign. Ionization energy is represented as plus sign as energy is accepted, or in the left hand side of the equation, and electron affinity is represented as release of energy, that is negative energy, or in the right hand side of the arrow. Now moving on to the next slide, the sign convention of electron affinity. Electron affinity is most often represented in terms of kilojoule per mole, or kilocalorie per mole can also be the mode of representation. Sometimes the values given in terms of magnitudes are relative to each other. In the value of electron affinity, or electron affinity is represented as EA is negative. If the value is negative, it means energy is required to attach the atom, as I said earlier, and negative values are seen for the nitrogen atom and also for most of the capture of the second electrons. It can also be represented as plus, that means plus energy, that means electron will be released from the outermost orbit of the valence shell. Now the trend of electron affinity, as I said, electron affinity is one of the trends that can be predicted using the organization of elements in the periodic table. These are all periodic properties that I started the class with saying. We will be discussing about the periodic properties, and electron affinity is one of the periodic properties of the elements present in periodic table. So it must have a trend, and the trend is like this, increasing from bottom to top and from left to right. Electron affinity increases from left to right. Now the question is why? Why electron affinity increases from left to right? Before going into that, we must say that the exception is in the case of noble gas. Electron affinity increases from left to right, but we know noble gases are at the extreme right of the periodic table. Even then, they have electron affinity approaching zero. Because the reason being, as we consider they are the noble gases, they have completely filled up octet. They have most stable electronic configuration. They have completed the octet rule and they have the most stable configuration. And electron will only be accepted or released when the configuration is not stable. Maybe they are lacking one electron in the outermost orbit, so that they will be accepting electron, or maybe having excess electron, or maybe having at least one or two electron in the outermost orbit, that they will be releasing electron. In both the cases, if the orbital configuration is incomplete, then comes the question of electron affinity or ionization energy. So we can understand electron affinity for noble gases is approaching zero, although they are placed at the extreme right in the periodic table, and according to the trend they should have the highest electron affinity, but they are approaching zero because of their stable configuration. And electron affinity also increases from bottom to top. Let us discuss what are the reasons for the variation of this electron affinity. The reason of the electron affinity being increasing from bottom to top or from left to right, let us explain. So how it can be done? Let us explain that. Probably I missed one slide. Anyways, let us explain, let us understand. Moving from left to right, what happens? In each case, one electron is added up in the same outermost orbital. That means one electron is increasing in the same outermost orbit and one proton is